Sorry for the delay. We had a little glitch here in going from part 1 to part 2. So if you're just kind of jumping in here at part 2 at number 12, we've noticed that we can do one positive and one negative because of a negative product. We know the bigger number is going to be negative because of the sum being negative. And we found our two numbers that are 14 apart, 2 and 16. So at this point, get those in there, and that would be my factored form of this quadratic. Now, this next one is another one that we'll be doing possibly after you see this for the first time. So again, if this is the first time, it's a nice little preview. What do I do when there's 4 terms there? Dang, the factoring is crazy enough with 2 or 3, but now there's 4. So my first job is going to be to pair them off. Once I pair them off, I'm going to do each problem separately. Okay, so in other words, we're going to kind of ignore this part. And we're going to look at the second part. We're going to say, okay, what do these two terms have in common? Well, they both have an x squared. Okay, I take the smallest exponent when we have a variable in common. And whatever's left over, I need the 2. I got 2 x's. I need 3, so I need one more. Here, I need the 3, but I already have the 2 x's, so I don't need any more. And I'm going to do that same process to my second set of parentheses. Biggest number that divides into 8 and 12, 4. What's left then? 4 times what gets me to 8? 2, and I need the x. 4 times what gets me to 12? 3. And that's what I'm looking for. If my sets of parentheses are the same, I did this right. If they're not, I got to go back and look because I did something wrong somewhere. So the factored form then becomes the set of parentheses that they share, only write it once. And then the other set of parentheses is my greatest common factors being put together. A lot of people like those once they actually see them and see what they're actually up to. Not even do a bunch of other fancy stuff. Just take out a common factor. All right, 14, we're almost there. Jenna was asked to show the complete factorization of the following polynomial. There's what she factors, that completely factored. Now, let's be serious. When you get a question asked like this, how often is the answer, is this completely factored? Yes. Like, never. Is this completely factored? No. If not, what is the complete factorization? There's our problem. That's a difference of squares. X squared is a perfect square, and so is 16. So what do you square to get each of those? I square x to get x squared. I square 4 to get 16. So, x and x, 4 and 4. And then since I'm multiplying to get a negative, one positive and one negative, the 3x will stay outside. Okay, so if you're asked if something's a complete factorization, the answer is no. And then you actually have to figure out what the problem is. Okay, don't just put x minus 4 squared. That wouldn't work. Because again, positive times negative gets me negative, and that's how that works. And then finally, use completing the square to rewrite the following quadratic equation into vertex form. Okay, completing the square, remember, it's all about b. We have it. We square it. That is the magic number. That is the magic number that gets added to my y side. That is the magic number that gets added in with my x's. Got to be those two places in that way. Once I get here, it's actually going to go fairly quickly. Because remember, we're going to get this down to the square of a binomial. And again, how do I get this number quickly and easily? Could I do foil? Could I do a diamond on this? Sure. I could just steal it from here, though. And then my last step is to get y by itself. Okay, ladies and gentlemen, this is your post-test. Well, with numbers changed around. And a few people's names to protect the innocent. That's what we're looking at here. We'll look at some more of these later. But again, go back through these, try them again, work something like that if you're having some trouble, and do really well on this.